Hello everyone, welcome to this video. In this video we have only one purpose, and that is to let you experience how we teach math in Spectra. So because the way we do it in Spectra is through a flipped classroom approach, where we actually let the students do their homework, meaning tutorials, in the classroom, and then at home they will be watching videos that actually teach them the basic of what they know in order to do the video. So it's like a flip approach where we do the homework in school, but we sort of learn at home. So what better way than to actually teach you today a chapter that you are going to learn in the near future. It's called equation of lines. You haven't learned it now, but you will learn it soon. I think maybe next month. Okay, so we're going to learn just part of this chapter, and I hope you will learn something useful. So let's get started. You can see over here we have a standard equation of a line in vectors. This is how we read this: r equal to 111 plus lambda times 123, where lambda can be any real number. So obviously we have a line, and then this equation is supposed to represent this line in vectors. So first of all, the most important thing that you have to get is that you must know what r is. A lot of people do their whole JC maths and they never really understood this point. Let me go through this briefly. Over here you have 111, a vector, right? And then you plus another vector, but you times a number. So essentially you have two vectors adding together. What would the result be? The result will actually be a vector. So R is actually a vector. And some people don't know this even until after they graduate from JC. Very sad. So in this case, it's not just a vector, it's a position vector. So the next thing you're going to ask is, how does this give you the line? Let me give an example. For example, when lambda is equal to 1, remember lambda can be any number. So if lambda is 1, what do you have? You have 111 from here, and then you got plus 1 times 123. 1 times 123, and the result is 234. So where is this 234? It's actually over here, and you can see this point is obtained when lambda is equal to 1, and this vector from the origin to this point is 234. So that's what the equation gives you, the position vector of a line. Okay, so let's look at another example. So in this case, we'll look at a similar example, lambda equal to 2. So in this case, it's the same story, but just that you change the lambda to 2, and you get 357. So in this case, it's over here. So this vector over here is 357, and this point over here is also 357. And you get the idea pretty quickly. And in fact, since lambda is a real number, it doesn't have to be a nice integer. It can be just funny numbers like 5.2, even 5.2344521, whatever. Eventually you're still going to get a vector. In this case, this is the point, and this is the vector that we get. Okay, so you quickly see how this goes on. As lambda becomes any number, you can represent every single point on the line, and that's how you get the line. In fact, lambda doesn't have to be a positive number, real number, right? -1 also counts. So in this case, -1 will give you this point. You sort of move backwards, and then this is the vector. Okay, so after we have gone through how you sort of get the line from this equation, we want to go through a few important things. First of all, how to draw a line. So let's say you are given this. How would you draw it on, sort of your working when you do questions? Of course, you draw a line first, and then you're going to draw this point, and in this case, label it 111. And then you're going to draw a direction vector and label it 1, 2, 3. Why is this so? Let me go through this. When lambda is equal to 0, you notice there's something happening here. Lambda becoming 0, it effectively removes this whole thing. Okay, this vector over here just becomes 0. So no matter what this vector is, it doesn't matter, because when lambda equals 0, this whole thing disappears and you're left with this. So what can we get from this is that 111 is definitely going to be on the line. So you can see this and this is basically the same. So when you see something like this, you know for sure 1, 1, 1 is going to be on the line. This is similar to your typical straight line graph in secondary school, y equal mx plus c. So when x is equal to 0, the whole thing gets eliminated and you get c. In this case, c is where when the line cuts the y-intercept. Where it cuts the y-axis. The next thing we're going to talk about is how do we get this part of the picture. Because you notice I draw a sort of a vector here to indicate the direction, and I label it 1, 2, 3. In this case, you notice this and this is actually the same. This is where I got it from. So what does this mean? It means that every time lambda increases by 1, effectively the line moves along whatever direction, and in this case, this direction by 1 unit. So this is again similar to what we call gradient in the straight line graph. Every time x increase by 1, your y increase by m. So this is effectively the gradient of the line to some extent, and in terms of vectors we call it directional vector. So this is how you draw a standard line, and please get this right to spare your teachers some pain, because students always draw this wrongly and it's very frustrating. So with this, we have covered all the basics of what you need to know for a straight line, for a line in the vectors. So we're going to go through a question, a typical question, to sort of see how all this knowledge comes about in a considered simple question. So in this question, we have quite a standard one. Write down the equation of the line L that passes through the point A and B, which is 2, 1, 3 and 6, 5, negative 4. So in any question for vectors, usually we want to draw out what we have so far. So in this case, we have a line, obviously, that passes through 2 points, A and B, and I label them accordingly. So we always say when we draw a line, we need to draw the direction, isn't it? But you notice, in this case, I do not know the direction, because they never tell me, isn't it? Okay, so of course they have the origin. So the next step we need to do is obviously to find the direction of this line. And you can see that actually the direction is from here to here, and this direction called AB is actually parallel to the line. Right, so if you can find AB, we are done. That is the direction vector. So in this case, what is the vector AB? It's actually OA minus OB. What is OA? OA is here, 2, 1, 3. OB is here, 6, 5, minus 4. So in this case, the direction vector will be OB minus OA, and you get 4, 4, minus 7. And this 4, 4, minus 7 will be the vector, this red color one, which gives you the direction of the line. So in this case, this is the direction. You can see that it's always this form, r equal to something plus lambda and times the direction. So what is this point? This point, it can be any point on the line. In this case, we have actually two choices. You can use A, 2, 1, 3 over here, or we can use B, 6, 5, negative 4 over here. Doesn't matter which one you use, but you must notice that I use different letters to represent these two lines, because these are different. This gives you the same line, but the same lambda and the same mu value doesn't give you the same point. So for example, if lambda is equal to 0, you get this point, but if mu is equal to 0, you get another point. So there's a slight difference here. Okay, but rest assured that both of this equation will give you every single point on this line. So this is a typical question that you will face in your tutorials. This is what I call basic mastery, and you will see different variations of a simple question like that. Some of the question will give you the direction and not give you other things. So from there you got to figure out what you need to find, and in essence it's always one point and one direction, and then you can just write down the equation of a line just like that. So hope you have learned some of the basic things in this chapter, and I hope that with this video you can do some of the questions we are going to give you at these stations. So thank you and bye bye.